Welcome to Persuasion Happy Data, Episode 2, Programming with R. First thing to do is open a new script. Load RStudio and create a new file, RScript. The first thing to do is make sure you have a working connection to R programming language. You'll find this in the Options under General in the R Sessions link. You should see a folder link there, otherwise you'll need to search for it. In a new programming language, the first thing I do is learn to print something to the screen. Here, we use the function print with bracket hello world. We'll now show you how that works. We select the code and we hit run. And on the bottom section here in the console, it should print the result. It also prints the function we ran. So here it says 1, hello world. The R interface is split into 4 sections. In the top left, we have the place where we code, or the R script. On the top right, we have the environment that records our variables. We can visually see what those values are. It's a very convenient place to track our data. Our console is the place we get our results and our error messages. And on the right, we have the R display where we can see our visuals and graphs. In R, we set variables with a backwards arrow, less than sign with a dash. We can see that X is set here to I am a variable. We can print that variable again using print. And class is a useful function to understand what type of variable it is. Variable types are important in R. Some functions won't work correctly with the wrong variable type. Here we'll run the first section on variables. First variable, X. I am a variable, print X and class. So run, I am a variable, print X. I am a variable, so we can see that if we can do these two things, and we'll also see that we've stored the variable on the right as X, I am a variable. Further, we can hit run class, and you'll see as we hit run, carriage returns to the next line, and it tells us that our variable X is a character variable, or string. Vectors are a very standard data type for R, one of the powerful components of R, because it allows you to store a single entity consisting of a collection of things, typically a collection of integers, numbers, characters, things like that. We can create an integer vector using 1:4, which creates an incremental vector from 1 to 4. We can see a value in that vector using the brackets with 1, gets the first record, and then we can print the first and fourth record. So the first vector we'll create is this vec_c using the C function, and we can use this. C is just a concatenation function. It creates a vector out of a list of vectors, and we can print that vector below, and you'll see that it separates them with tabs. I am a vector. Further, we can create that integer vector we just described. Vec_int, we'll see in vec_int we have an integer 1 to 4, so that means there's 4 values, and we'll see those values there, and we can see the first value is 1. They add the L next to it just to indicate that it is an integer rather than a number. Then we can see the first record and the fourth record are 1 and 4 accordingly. R has a number of functions to read information about objects, such as class, which tells you the type of variable, is numeric, which tells you if it's a number, could be decimal or integer, is integer, will tell you if it's just an integer, is character, will tell you if it's a string, and length will tell you the size of a vector. Here we can see that basic info in action. Class is integer, is numeric is true, is integer is true, and is character is false. We'll see the length of the vector, or the number of records in that vector is 4. R supports multiple grouping type variables. So these allow you to get summary statistics of a vector. We see the mean, the median, the summary statistics, min, max, range, sum, variance, standard deviation, and quantiles. We can convert a variable into a number using as numeric. again, similar basic info as before. Numeric, true, false is not a number, false. And now we'll have the mean, the median, the summary statistics, so it includes a whole bunch of different statistics. Min, max, 1 and 4. Range, min and max together. The sum is 10. Variance is 1.6. Standard deviation 1.3. And the quantiles are below. Finally, we could do mathematics quite easily with vectors. This will take any number of vectors and add, subtract, multiply, divide, or take them to the power of another vector or the same vector. Finally, logical expressions use if-else function with the logic expression on the left. If true first, then false. Uses the and sign, vertical line, exclamation mark for and or not. Double equals for equals to, and exclamation mark equals for not equals to. Starting with creating a number of different values here, we'll start creating vector A, B, C, E10, which is just a series of 10 power variables, cycle 2, and D. We can see A plus B is 6, 8, 10, 2, 12. A minus C is all minus 8s. B plus C, and so on and so forth. A times A, 1, 4, 9, 16. A to the divided by B. And so you can sort of play with these different calculations. You can see the results below. I'm not going to go too much into them. You'll see if there's a different cycle length variable, you're going to have problems because it's going to cycle between, it's going to reuse cycle 2 twice. So it'll use the first 2 and then it will go back to the beginning to make sure they match. So it's typically a good practice to make sure the variables have the same length. And finally, we can do logical expressions using if-else. So if-else allows us to take the logical expression here, and then if yes, 1, if no, 0. And we'll see if we run this, it's going to create a new variable. Over here, if A, the first variable is 1, the other ones are not 1, so they're all zeros. If not 1, we'll see it's just the reverse of that. And so we end up with 0, 1, 1, 1, again on the far right here.